This is the first video of a series of videos on volume and surface area of 3D figures. I wanted to start before we get into those formulas to kind of define the different figures that we have. Each one has a different name and it's based off of its defining characteristics. If we look at the first one, we have a square prism. The word prism just means that we have two identical shapes on the edge that are connected by some height of some kind. Okay, for a square prism, that shape on the end is going to be a square. And we can see that because we have side lengths that are the same value, and we also see 90-degree corners. Those are indicators that this is a square on the edge, which makes this a square prism. The second one is a rectangular prism. See how it has a similar shape to the square, but instead of a square, the edge here is rectangle. Okay, again, we can see that because we have 90-degree corners, and we also have two different side length values for that rectangle on the edge. And again, two rectangles running parallel that are connected by a height. The triangular prism is just like the square and the rectangle, but the edge is a triangle. Okay, so on that edge we have a base of the triangle, we have a height of the triangle, and then we also have a height of the overall prism. Okay, so make sure you're careful with these letters here. One is a lowercase and one is a capital H. The lowercase h is the height of the edge of the prism where the triangle is, and the height is the distance between those two triangles on the edges. The last one is a cylinder. Cylinder is not technically considered a prism, but you can think of it kind of like a circular prism because you have two circles that run parallel and are connected by a height of some kind. Okay, and then on those edges where we have the circles, we also have a radius in that circle, which we can use in our calculations to figure out volume and surface area. All right, the other four figures are pyramids, cones, and spheres. So pyramids have a base shape of some kind, and then they connect up at a common point. So all the edges get pulled up into one common point. So instead of having two edges that run parallel to each other, we have one base shape that's pulled up and connected at a single point. Okay, and the first shape we have here is a triangular pyramid. And if you can look at the bottom here where these black dash marks are, the base of this pyramid is a triangle. Okay, and when we're looking at the letters that are defining this shape, we have a lowercase b here that represents the base of the triangle. And then the red dash mark here has a lowercase h on it that represents the height of the base of the triangle. Okay, used in calculating area and volume. And then the pink dashed line here with the capital H represents the height of the overall pyramid. So from the center of the base triangle all the way up to the point at the top. And then the last letter here, L, represents the slant height. It's the height from this edge to this point. It represents the slant height. Okay, the other kind of pyramid we're going to look at is the square pyramid. So just like the previous pyramid where it was a triangle base, this is a square pyramid, so we have a square base here. Okay, that's noted here with the side length S. All of these side lengths are going to be identical because we're dealing with square. We have the pink dashed line going up the top. That's going to represent the height of the overall pyramid, just like with the triangular pyramid. And L, again, is going to represent the slant height. It's the length from the base, the edge of the base, to the top of the pyramid. Okay, cone is very similar to a cylinder. in that it's kind of can be considered a circular pyramid. Technically, that's not a real name, but it is a good way to think of it. It's defined as a circle base that's pulled up by its edges to meet at a common point. Okay, so we have on the base, where we have the circle, we have the radius of the circle. And then from the center of the circle all the way up to the top of the cone, we have the height of the cone. And then we have length L here, which represents the slant height from the edge of the circle to the top of the cone. The last shape here is going to be our sphere, kind of like a ball, or yeah, I think the best way to describe that would be a basketball. And so from the center of the sphere to the edge of the sphere is going to be the radius. Kind of think of like a radius of a circle, but we're thinking three-dimensional. So not just a circle, more three-dimensional like a ball. Okay, so that's a basic rundown of the 8 shapes. Keep watching the videos in this playlist so that you can see how to calculate the volume and the surface area of each type of shape.